Good morning, students. We'll be starting with our chapter 7 of our syllabus, which is a part of unit 4. We have pending sixth chapter, that is deadlocks, which is a part of unit 3 that will continue after chapter 7. Um, the unit 4 has two chapters again, chapter 7 and 8. Chapter 7 is virtualization and the cloud. Again, it has one more part, that is multiprocessor systems, that is chapter 8. So today we'll be going with virtualization and cloud. So virtualization, again one concept, and the cloud is another concept. So today we'll see what is virtualization. Before that, we'll bifurcate and understand what is virtualization, and then we'll move on to the further process. So first is virtualization and virtual. When I say virtualization, this word virtual means not real. The word not real here means we can imagine it, we can use it, but it's actually not existing. That is called as virtual. Virtual means, if you check the meaning of virtual, means it's imaginary, it's not real, but people accept it as it is there and work on it. That is called as virtualization. So basically, we'll see what is history, why virtualization technology was being used. From availability and security point of view, using separate computers to put each service in more is more preferable by organizations. If one server fails, another will not be affected. It is so beneficial in case if organization need to use different types of operating system. See, means here, if we see it with the help of availability and security, both types. Availability means at this particular time I should be available with this all resources what I want to complete my task. Security is when I am working none of my data should be lost anywhere, should not be used by somebody else. That is security. So these two point of views, that is availability and security, when we check while working on the operating system, the task what we get are first one that it should not fail. Even if we are working for 10 hours, 12 hours, the system should not fail, the system should not reciprocate that yes, the system cannot function further. That is the first thing, the crucial one. Second one is it should do multitasking at a time on single operating system. That is, when I say I want to complete a particular chapter, what resources do I want? I want my book, I want a resource to communicate and the explanation. But for it, what I want is all the students should listen to it at one time. So for that, what I want is I want multitasking. I'm not explaining each and every topic to every single student. I am explaining my topic once, but that is for n number of students and that is called as multitasking. So for multitasking, also virtualization is necessary. Third one is that I have a particular storage that is clustered or connected together so that I can do my work easily. That is, if I have one operating system or two operating system working on single system, but if my system fails, my operating system cannot do anything. Rather, if I have two systems connected together on one LAN PC and I have a shared storage of that system as well, what I can do is the current PC on which I am working, if that fails, I can use the storage of the system which is connected with my system of operating system for storage. These are the three criteria in which my system can work as virtual. When I say virtual, it has a virtual machine monitor, that is VMM, which creates an illusion. Illusion means an vision that is somewhere virtual, that is not real, but people accept it as it is existing and we should use it. So, the virtual machine monitor creates an illusion of multiple machines on the same physical hardware. That is, on single hardware storage, it will connect n number of systems on a LAN so that people can use the storage, share the data, and connect to it. So a virtual machine monitor is also called as a hypervisor. Keep this in mind. A VMM is called as a hypervisor. That we'll see further what a hypervisor does. But somewhere it is connecting n number of systems on a physical hardware or a single hardware to share the data or to share the task or share the storage. Using virtual machines, it is possible to run legacy applications on operating system. So n number of applications can be run on virtual machines. So we'll go further. What is actually the concept of virtualization? An organization has multi-computer but does not actually want it. A common example is where a company has an email server, a web server, and an FTP server, some e-commerce servers, and others. So what they have said is they have different systems, that is multi-computer, but they do not have the proper work done on it. That is, every system has different servers on it. What is the use if one server does not work? Rather, if I install all the servers on one system and then accordingly work on their shared storage, that could be easily possible. So these all run on different computers in the same equipment rack. So this all together work at a single time on the different computers, but they do one single task at a time with all connected by high speed network, in other words a multi-computer. So if they want to work together, they require a high speed network, that is a multi-computer system. Isolation and fault tolerance are achieved this way. This solution is expensive and hard to manage because so many machines are involved. Isolation, that is bifurcation, is not possible. Separating something. Fault tolerance means if problem occurs, solving that also is somewhere difficult using multi-computers, and it is expensive as well. There are just two out of many reasons for keeping separate machines. So there are no such actual reasons on which you can say for separate machines to work on. It can be a shared storage or a shared network. For instance, organization often depend on more than on one operating system for their daily operations. Yes, obviously, it's not compulsory companies or organizations are only working on Microsoft or only working on your Windows operating system. There is Mac, there is Linux, there is BSD, there is Unix, there is what you say Apple OS. All such things are there. People are working with their preferences over operating systems. So and their task also can be different. Nowadays people are more preferable with Windows, but if their tasks are different, they can prefer different operating systems. Upon what to do, actually what is virtualization, what do they do is, a possible and a popular solution is to use virtual machine technology. Rather than going for a number of machines to connect, we can go for virtual machine technology, which sounds very hip and modern. So virtualization, when we talk, one thing which comes in mind is it's not something new into the era, but the idea is old. The idea of connecting these systems over one was old. Priorly people used to do this with a number of we can say extended hardware. Nowadays people have a very minimized hardware and the connection possibilities are also very easy. It was from 1960s. Even so, the way we use it today is definitely new. Yes, the technology, as I said, is somewhere new. The main idea is that VMM, virtual machine monitor, creates an illusion of multiple machines on the same. So it creates one single interface of all the machines on one system so that they can work easily. So what are the requirements of virtualization? So there are basically three requirements: safety, fidelity and efficiency. So hypervisors should score well in three dimensions. So your particular hypervisor should work properly, that is at a time it should do multi-computing task with these three dimensions. That is, first one is safety. Hypervisor should have full control of virtualized resources. If my system is being virtualized with some another systems, it should have resource sharing which is safe. Data should not be lost. So this is the first thing. Fidelity is behavior of a program on virtual machine should be identical to same program running on the bare hardware. That is, if I am running some music on my actual system, the consistency what it is giving me on the system should be the same while it is accessing the actual hardware of the system. That is, through software or hardware, the consistency of the working should be the same. Third one is efficiency. Efficiency is much of code in virtual machine should run without intervention by the hypervisor. So there should not be any interference on the processing of virtual machine by the hypervisor. Hypervisor just should create a platform for using a number of machines. An unquestionably safe way to execute instructions is to consider each instruction in turn in an interpreter and perform exactly what is needed for that instruction. Some instructions can be executed directly but not too many. So rather than going execution one after the other can easily be made possible. So when I talk about hypervisors, there are two type of hypervisors, that is type 1 hypervisor and type 2 hypervisor. So type 1 hypervisor is only, type 1 hypervisor is the program running, is only the program one type, which is the privileged mode. So it is just like operating system on the top of the hardware. So can you see this part 1, that is you have your actual hardware, that is your network, disk, CPU, everything, and you have hypervisor. Now on this hypervisor you have all these type of operating systems. In a normal system, what do they do? For one single operating system, so one single hardware, they have one single operating system. But in a virtualized machine, if you are using an virtual machine monitor, that is a hypervisor, what do you have? You have an in one hypervisor on which they are sharing the same hardware of the system with different operating systems. Now here, as the diagram says, it is Windows, Linux. Now it's not compulsory it can be Windows and Linux, it can be OS X, it can be BSD, it can be Unix, a number of operating systems connected over an hypervisor to share a single hardware. Next is hypervisor. Now the main function of type 1 hypervisor is to offer multiple copies of real hardware. So it is creating multiple copies of my hardware so that they can process for Windows, Linux and control domain. Then they are also called as virtual machines. Each and every operating system will be called a virtual machine in the same way as the process of normal operating system runs. Like they will be separately shown to the user who is using. So it looks just like the same how the person uses operating system in the normal machine. Next is type 2 hypervisor. Now type 2 hypervisor is bare metal hypervisor. Why bare metal? Because type 2 hypervisor depends on host operating system to allocate and schedule resources greatly similar to regular process. So there is somewhere a difference between your first diagram and your second diagram. That is, your type 1 hypervisor only creates a platform to share the resources. Here you have guest OS, you have host OS, that are separate bifurcations are done. That is, certainly type 2 hypervisor still makes us believe to be complete computer with a CPU and various devices. Now you have a single hardware here for type 2, but what you have is you have an host OS, that is my actual system OS is Linux. Now there is type 2 hypervisor which is giving me guest OS as Windows and host processes running at the same time. So, two simultaneous operating systems are running with their own hardware systems shared on one single hypervisor is called type 2 hypervisor. So, both hypervisors have to execute the machine instructions set in a safe manner. So, both can simultaneously work on their particular instructions. For example, an operating system running on the top of the hypervisor may change, even spoil its own page tables, but not others. So it can work for their own, they can spoil their own data, but not the others as they are separate. At the first startup, it proceeds like newly booted computer except to locate a DVD, USB drive, CD-ROM having an operating system in the drive, which could be virtual device. So virtual device rather at the starting booting stage will not access your pen drives, your USB drives, your CDs, DVDs, all such things. Then virtual disk tries to change the authentication process. So there are types of hypervisor, types of methods, or we can say virtualization methods. So there are basically four methods. I'll repeat means I'll tell one by one. First one is virtualization without hardware support. Second one is para virtualization. Third one is virtualization with hardware support, and the last one is process virtualization. So these are the four methods in which your hypervisor is working. So when I say the first method, that is virtualization without hardware support, so the type of server is ESX server 1.0 for type 1 and VMware workstation 1 for type 2 hypervisor. For para-virtualization method, type 1 hypervisor uses Zen server, and there is no type 2 hypervisor for para-virtualization as multiple resources are being shared separately over type 2 hypervisor. Virtualization with hardware support have vSphere, Zen, Hyper-V on hypervisor 1. VMware Fusion, KMV Parallels are the flavors, or we can say types or versions of type 2 hypervisor in third method. Next is process virtualization. Process virtualization cannot be done for type 1 hypervisor as there is no sharing of processes over operating systems. Wine is one version of type 2 hypervisor in process virtualization. Then there are techniques of efficient virtualization, how your virtualization technique works. The first one is, the most significant issues are virtualizability and performance. So giving you virtualization process as well as that is making it virtual, and it should also maintain performance, are two different variations which a person has to maintain while virtualizing a particular environment. Consider a type 1 hypervisor supporting one virtual machine, and as said previously, it runs on the top of the hardware. So typically your type 1 hypervisor works on your top of the hardware. So if we are considering it as type 1, what are the techniques for efficient virtualization? The virtual machine runs on as a user process in user mode. Virtual machine will run on the user mode only. Then and denied from to executing sensitive instructions. It would not be helpful for machine instructions to be followed. On the other hand, virtual machine runs a guest operating system that imagines it is a kernel mode. So guest operating system is also running on the kernel mode, that is the main system operation. Actually, it is not in the kernel mode. It is not actually in the kernel mode. It is just performing the task in the kernel mode, and that is called as virtual kernel mode. The virtual machine also runs user processes which are actually in user mode. So virtual machine can also run these user processes in the user mode also. Now guest operating system imagines it is an in kernel mode. What guest operating system will think? That yes, it is in the kernel mode, I can work and execute my instructions permitted to me by the CPU in reality. So there can be chances of failure if CPU does not have a virtualized time session. If it does not support virtual technique, then it should or in third case, either if user is working on multitasking, virtual mode can be stopped somewhere from processing or throughput. With this, we'll stop here for this lecture. We'll continue the next topic in the next lecture. Thank you.